Hello everyone. Let us do a numerical problem based on electric flux density concept. Let us read the question and try to understand. We are asked to determine electric flux density d vector at the point P due to a point charge, an infinite line charge, and a surface charge. Let us start giving the numerical problems formula and then start with the substitution. So I will write the formula to find electric flux density due to a point charge. For point charge, it is given as Q by 4 pi into R vector divided by R cube. And for line charge, the formula for D vector is rho L by 2 pi rho A rho cap, or you can write in terms of vector R as rho L by 2 pi into vector R divided by R square. And for sheet charge or surface charge, flux density can be found as rho S by 2 A n cap. So we should know what are these individual vectors. So for point charge, I'm giving subscript RP, and for line charge, I'm giving subscript RL, and for surface charge, I'm giving subscript S. So let us start with the point charge problem. So we have to find what is the vector R from the charge to the point P considered. So let us start with the first one for point charge. Point charge of 30 millicoulomb is located at origin. The coordinates of the point charge is origin. And the point P where we are finding electric field intensity or flux density, that is 6, 8, minus 10. So when we try to find the vector from charge to the point P, we have to find RP vector and then make the substitutions. So RP vector is 6 minus 0, that is 6AX cap, plus 8AY cap, minus 10 AZ cap. And magnitude of RP is under root 6 square plus 8 square plus 10 square. So we should estimate it. I'll take the calculator and do the estimation. So it is under root 6 square plus 8 square plus 10 square. So which is 10 root 2, which is 14.14. I'll write 10 root 2, which is 14.14. Now we should find what is flux density D due to point charge. We can start writing in the formula, which is Q by 4 pi. So 30 milli divided by 4, sorry, it should be milli. 30 milli divided by 4 pi into vector R, which is 6AX plus 8AY minus 10AZ divided by 10 root 2, the whole cube. Now we can use calculator and compute this. So which is 30 milli divided by 4 pi into, or I can write the denominator value also, 10 root 2, the whole cube. So this has to be multiplied with 6, which is 5.06 micro. So I'll write 5.06 AX cap. All the terms we can give in micro, 10 power minus 6 coulomb per meter square. Then for y component, this has to be multiplied with 8. So it is 6.75 micro. 6.75 AY cap minus, and instead of this has to be multiplied with 10. So it is 8.44 micro. 8.44 AC cap. So this is electric flux density due to point charge. Next, we should find electric flux density due to line charge. So we can start with the line charge consideration. So I will consider the line charge along z-axis. So this is the second subdivision. Line charge along z-axis. It carries a charge density rho L of 40 microcoulomb per meter. And the point at which we have to find electric field intensity is 6, 8, minus 10, or electric flux density we should find over here. So a similar procedure for a line charge we should do. Draw a perpendicular from the point P to the line charge and find the point of intersection P dashed. The coordinates of P dashed will be required to find what is the vector RL, and we have to substitute the vector RL and its magnitude into the formula to get electric flux density. So when we consider here z-axis, equation of z-axis should be given as x is equal to 0, y is equal to 0, and z can take any value from minus infinity to plus infinity. So everywhere on this line or z-axis, x value is 0, z value is 0. The value of z will be taken corresponding to the point P because we have drawn perpendicular from the point P. So when we are drawing perpendicular from point P, the z coordinates of P will be same as the z coordinates of P dashed. So we should write here, this is minus 10. Now we can get what is RL vector. RL vector is 6ax cap plus 8ay cap, and z component will get cancelled. Now magnitude of RL is under root 6 square plus 8 square. We can calculate it using calculator. So under root 6 square plus 8 square will give 10. Now we can substitute in the formula for line charge to get the flux density due to line charge. So we have this rho L value and RL values to be substituted. Rho L is 40 micro divided by 2 pi, and R square, which is 10 square, and in the numerator it is 6ax plus 8ay. We can make use of calculator and compute the value. So 40 micro divided by 2 pi into 10 square. This has to be multiplied with 6 for the x component. We should get the value in micro. So let me get the value in micro. That is 0.381 micro. 0.381 ax cap. So everything is in microcoulomb per meter square. Then for y component, it should be multiplied with 8. So we should give in micro, it is 0.509 micro. 0.509 ay cap. So everything in micro, you can write 10 power minus 6 coulomb per meter square or microcoulomb per meter square. Next, we should do surface charge consideration. So for surface charge consideration, the surface charge of charge density 57.2 microcoulomb per meter square is present on a plane z equal to minus 9. So we can do that separately now here. For surface charge, the formula is d is rho s by 2 a n cap. So let us try to understand this surface charge thing first. The surface charge is located on a plane which is at z value minus 9. And the point P where we have to find flux density has the coordinate 6, 8, minus 10. So when you look at the value of Z here for the point, it is Z equal to -10, which is below this sheet. Or I can write a point P with the coordinates 6, 8, -10 below this sheet. So when we look at the flux density vector, it will go downward. So this will be the direction of flux density. It will go downward. Or you can write the formula for flux density due to surface charges, rho s by 2. Rho s by 2 a n cap. Now this a n cap should be determined. A n cap is the unit normal. A n cap is unit normal from sheet to point. So from sheet to point, what is the direction it is going? So from sheet to point, the direction is downward in z direction. From sheet to the point, it is downward in z direction. So we should write a n cap as minus az cap. The rest of the things, you can make the substitution. That is, rho s is 57.2 micro divided by 2, which is in minus az direction. So when we take this 57.2 division by 2, you'll get the magnitude, which is 28.6. So the flux density for surface charge will be 28 minus 28.6 az cap micro coulomb per meter square. So we can write 10 power minus 6 as micro coulomb per meter square. So you can go through this problem again for a better understanding. Thank you for watching the video.